like a quantum driver, for instance, you see an advert, quantum driver, and you
Driver.
Driver.
Like a
Car.
Yeah.
What? Hi guys, so today I came across this particular article. It's titled Quantum Computing Hype is Bad for Science. It's by Victor Galitski. He's a professor at Joint Quantum Institute. So this article is obviously calling out the fact that this quantum technology field has been overhyped and people are now expecting much too much from the field. So this is nothing, I guess, new. In the last 5 years, people have been going crazy over quantum computing. There's been new startups coming in left and right. Google and IBM are making their own quantum computing things. People are talking about it. So what we're going to do today is to have a read of this article and have a look at whether these arguments stack up. All right, so let's have a look.
Unless you've been living under a rock, you've never...
Okay, it's too boring.
I'm gonna laugh.
Okay, let me try and read. Okay, so unless you've been living under a rock, you've probably noticed the recent proliferation of striking headlines about revolutionary developments in quantum science and technology, amazing recent successes of world-changing quantum startups, and huge government and private investment in quantum computing to capitalize on the imminent second quantum revolution. That's a Dowling quote, right?
Yeah.
Being a bit familiar with quantum physics and having recently spent some time trying to understand how the new quantum industry operates, I'm getting more and more concerned that this recent quantum computing commotion is a self-perpetuating intellectual Ponzi scheme, a bubble which may sooner or later crash and take legitimate research and innovation efforts down with it. To be sure, there are gems in this quantum technology space, but they are far and few between. Most ventures are questionable at best and are kept afloat by a huge and growing influx of funding, which is not based on any rational thinking or reasonable expectations. Any comments so far?
It may not really live to the expectations, but there are some few technologies that we develop along these lines, but maybe we might not really get to big hype we are seeing. In that sense, it may not really be totally Ponzi scheme, but as for being hyped, yes.
Also, I'm not sure I would call it a scam, but I would say that there is a huge gray area, and many companies are just feeding on the fact that it's a gray area, and it is a sort of abuse, but I'm not sure if I would call it a Ponzi scheme. Indeed, I would agree that after a while we might all pay price for this abuse.
It appears that the US government is pouring money into quantum because China seems to be doing the same. China is doing it presumably to compete with the US and EU, all racing to build a quantum computer. The same logic probably, I'm so used to saying logic probably. The same logic probably applies to the major big tech companies. Company G does it because company M does it, and vice versa. Certain deep tech VCs want quantum in their portfolio, not so much because they believe it will actually work, whatever work even means in this context, but to spice up their portfolio with cutting-edge quantum stuff. It is often a purely PR move to lure unsuspecting investors who have no idea what's going on but don't want to miss out on the world-changing quantum computing efforts.
To start with, does G and M connote Google and Microsoft?
I think this paragraph actually sort of explains the dynamics behind it, because I don't think investors actually care if there will be quantum computer or not. What investors care about is the value of the stock they own to appreciate. So hype is actually good for them. They don't need to know much about quantum, and they don't care about quantum probably, and they don't care if it works out or not. What they care is when they cash in, when they sell the stock they own, has to be 10 times worth, 10 times more worth than when they purchased it.
So they're actually just investable terms, but not
Yeah, okay.
idea of the
And that's where the worry comes from, that there might be a crash when all of the hype.
Yeah, so the last people who enjoy it will be the losers.
Yeah.
Continuing, so this creates an unhealthy situation where there is too much easy money poured into a small niche nascent field where the hype is based on unrealistic and in some cases simply false expectations. Crazy headlines abound. Quantum computing will change life as we know it. Quantum computing will solve global warming. Quantum computing will revolutionize science and industry, etc., etc. These statements are not based on any research or reality at all. They are not even wishful thinking. The number of known quantum algorithms which promise advantage over classical computation is just a few, and none of them will solve global warming, for sure. More importantly, exactly 0 such algorithms have been demonstrated in practice so far, and the gap between what's needed to realize them and the currently available hardware is huge. And it's not just a question of numbers. There are qualitative challenges with scaling up, which will likely take decades to resolve, if ever.
This paragraph is really.
It's just like our Bitcoin video. It doesn't, quantum doesn't really help you that much as people want it.
He's uncharacteristically pessimistic, actually. Like 5 years ago, everybody was saying, it'll take decades to make. And then just very recently, everybody suddenly decided, it's just a matter of time. It's like all the technology problems are solved and it's all going to be here. It seems to be fashionable these days just to say that, quantum computing is sort of solved, right? But I sort of tend to agree with him that it's not a completely solved problem. If it was so solved, then people wouldn't be trying still all these different technologies. Like if you look at all the different quantum computing companies, there's one doing photonics, one's doing superconducting qubits, ions, and not all these technologies are going to survive in 50 or 100 years. So it's still really completely working things out. It would just turn to industry to do it now. Arguably, there have been successes in quantum simulation, but here there is a problem with definition. What does quantum simulation actually mean? So far, it has mostly involved doing the same experiments quantum experimentalists have been doing for decades anyway, but renaming the observed phenomena in a quantum information-friendly way. So, for example, one can title a paper with identical content as either observation of Mott insulator with whatever, or quantum simulation of a Mott insulator with whatever, quantum computer. The former will result in an unremarkable publication in a modest journal. The latter will be welcomed by a high-impact scientific magazine, receive prominent news coverage and potential investment into the revolutionary quantum simulation technology.
I'm not commenting on that one.
I'm not either.
Yeah, didn't you have a paper that's like emulation of something?
No.
Yeah. No?
No.
And didn't you get it into a good journal? Yeah.
No. Fine, I did.
Well, that's the reality of the world we live in, okay?
What about quantum chemistry? Because people often cite quantum chemistry as a great application of quantum simulation.
Yes, they do. We're still very far away from any practical applications of quantum computing to problems in quantum chemistry.
I saw several papers where they say that they've simulated some molecule, was it hydrogen, with a relatively small scale quantum computer.
Again, how do they confirm that these simulations are accurate? Of course, they compare it with the classical, what you get from the classical case. And a lot of these systems you can solve in seconds with a classical computer. They haven't presented much of an advantage yet. But the fact that they're doable is promising. The comment out there that knows what the largest molecule they've done so far, please be sure to subscribe to this channel.
One can argue that there is nothing wrong with this modus operandi, as even if quantum computing does not deliver on its promises verbatim in the visible future, it won't, or never materializes at all, something good will still come out of this activity. This is actually true, and there has already been some intellectually lively research activity with a number of exciting ideas of relevance to fundamental science spun off by the quantum computing hype. But there is also way too much noise and intellectual junk. It's a bit like what you were saying.
Yeah.
Yeah. Problem is that the aforementioned situation with the wild influx of quantum money creates incentives for people with no relevant background or abilities to jump into the quantum field and take advantage of it while the quantum bonanza lasts. There are many quantum startups and initiatives which are promoted and often led by individuals with no relevant expertise or education. It is virtually impossible to make a meaningful impact in this high-end scientific research without proper education and experience. A successful company in the quantum technology space cannot pop up like Facebook or TikTok or a similar dumbed-down platform based on a code written by a college dropout. Ooh. Ooh. What's needed is years of education, work, and dedication. But what's going on is that there is an army of quantum evangelists, an actual job title by a prominent quantum startup, who can't write the Schrödinger equation, or maybe don't even know what it is, but promote the fairy tales about the bounties of quantum computing revolution, which is supposedly just around the corner. They raise millions of dollars for their startups, which are guaranteed to go down the drain.
Okay.
I think someone
That's
is...
serious.
So he doesn't want the stock of years of education and quantum information to go down because
Yeah.
of this hype.
Yes,
It seems.
it's a point, yeah.
I think I agree that knowledge and education is required quantum technology startup, but I wouldn't exaggerate that it's the most important thing and put too much emphasis on that, because I think people who are too much in academia, also in quantum related fields of academia, I don't think they will be capable of making a successful startup, honestly. I mean, maybe they can write a paper or 2 papers or 3 papers per year, but they know nothing about business, about talking to investors, managing funds.
Usually, when you go to business, it's not the high-end results that actually matter. It might actually be the basic results of all those things, actually. In a way, even though you might say, okay, this field requires people with, high-end education, high-end this, but I must have worked in the field for X number of years. But actually, when you look at the actual technology that comes out that might be commercially available, you find out that maybe those high-end results we are looking for or you are targeting at are not actually what goes into the making of this technology.
And continuing from where you...
Yeah.
I think maybe sometimes it could be an advantage of not being too much in the field, because you tend to get polarized and repeat what others think and others do. And you sort of forget about other directions.
One may counter by asking, who cares? So VCs want to fund quantum startups to spice up their portfolio. So why is it a problem if some people get rich in the process and some investors lose money? Taken out of context, it is not a big problem per se, but it seems to produce a chain reaction of potentially more damaging consequences. I list some presumably undesirable scenarios. So number 1 is brain drain of true talent. Apart from unqualified quantum engineers who poison the field with junk science, it is understandable that many actually smart and gifted students, postdocs and senior academics also want to participate in the quantum bonanza while it lasts. It appears that in many cases, but not all, as there are certainly QC efforts which undoubtedly produce top-notch fundamental research in basic science, this leads to the situation where the researchers are forced to quit activities they are actually good at and where they could have made real impact and joined the QC hype with its own weird rules. So talent migrates from legitimate science into quantum evangelism with no content. Some do make money, to be sure, but waste their gift and intellect on selling quantum snake oil.
Do you want a glass of water or something?
In a way, this can sort of happen even just in academia
Yeah.
itself, because there are certain hot topics and then so much pressure to publish and sort of chasing after these topics that people will be attracted by because it's the hottest thing now. If you just keep on the hot topics, then you can have a successful academic career. So in a way, there's the same kind of thing in a different format.
And let's not forget that legitimate good ideas were rejected by science many times and delayed by decades or very long time. So
Speaking of funding, it's funding agencies who already have made up their mind that now they're funding quantum information science or quantum computing projects, and maybe your idea is way off from this channel. You find out that it's very difficult for you to be able to get funding, even though you have brilliant ideas. You need money to really run these ideas. So what you do now, okay, I have this idea, maybe I'll be working at it at my spare time, but in the meantime, let me look for someone that will give me money so that maybe I'll get some money to even run those ideas that are brilliant, but nobody is going to sponsor. It drives people to this kind of thing. He's saying abandoning what you are really very gifted at doing into doing something because that's what is involved. But actually, I think the society is wired in some way like that.
Okay, number 2, quantum Ponzi schemes. Another danger is the appearance of not only intellectual but actual old-fashioned Ponzi schemes to sustain QC startups for as long as possible. Unlike Theranos, where the underlying technology was supposed to be simple enough and so it was relatively straightforward to detect fraud, quantum technology is actually complicated. For example, one service QC companies can provide is access to their quantum hardware on the cloud hosted by big tech companies. Using these platforms, developers can write quantum codes and experiment with quantum computing. Truth of the matter is that both now and in the foreseeable future, there is nothing that a few qubit quantum computer can do that your old laptop cannot do. It is unclear how exactly one can verify that a quantum code actually runs on a quantum computer instead of a classical node inserted between the cloud and the quantum computing provider, and there is a huge window for fraud there. Another dangerous element here is that there could be customers where data security is paramount, like banks, etc., who may choose to use the quantum computing service just for the publicity's sake. Imagine a headline, Bank X adds quantum computing to its toolbox to protect customer data, without actually caring much about the content. So even if there is a $700 laptop between the cloud and the quantum computing hardware doing all the work, it wouldn't matter too much. Everybody is happy. The quantum computing company sells its service, the bank gets the attention-grabbing headline of quantum security, and the VC recoups its investment in the quantum technology that makes a dent in the universe, part of an actual quantum job description by one of the big tech companies. Position is still open at the time of writing. But something is obviously wrong with this scenario where fake science is promoted. There are, of course, many more opportunities to fool investors and the public in such a complicated space. But the Ponzi schemes cannot continue forever, and sooner or later they tend to crash, wiping millions of dollars of investors' money. Well, yeah, if that happens, then of course.
Problem.
Yes.
If someone already get
problems.
like this, that will be a problem. Yeah, for sure.
So are you guys aware of the Theranos?
Yeah.
But yeah, what is exactly that Theranos?
So there was this entrepreneur who came from Stanford, actually the same department. Elizabeth Holmes came from the same department too.
Same department as what?
Bioengineering.
Oh, okay.
Yeah, both.
It was something like you just take a micro blood sample,
Yes.
and then you could test for myriad of diseases.
Yeah, it turns out that sort of high throughput blood test turned out to be a huge fraud. Her company went down the drain, and so did investors' billions of dollars worth of investments.
Wow.
And if I'm getting these details wrong, remember to type a comment and subscribe to this channel.
Oh my. Number 3, arguably the worst possible outcome would be damage to the reputation of science as a whole. It's bad enough that some fields of science epidemiology, climate science, etc., have been unnecessarily politicized, and where some research results and conclusions cannot be just published and discussed in an open and unbiased manner. Fortunately for the exact sciences like math and physics, it has not been really a problem there just yet. However, now some STEM fields are facing a different danger. The manifestly false promises of quantum computing routinely made by unqualified individuals and the high potential for fraud in the less than transparent business schemes of the QC companies operating in a fake it until you make it market all but guarantee an eventual collapse. Investors will be eventually asking questions, taxpayers will be eventually asking questions, but there will be no good answers. The likely downfall of this enterprise could irreparably damage the reputation of science and scientists across the board. But for now, the quantum house of cards is simultaneously both alive and dead.
Nice analogy.
Yeah.
Does it feel like he's extrapolating a bit too much? Like the fact that it'll all come crashing down?
I think he's trying to say that maybe physics and math has to be vigilant so that their field doesn't get whiplash like other ones. But I don't think so.
Yeah, I don't think physics will come down, crashing down.
Yeah, I don't think physics will come crashing down.
Quantum computing could have a bad name to it.
I think it will always survive because I think once you disprove it or once you reach your limit, you've reached your limit and life goes on.
I think that's why it's very, very important to rush and develop quantum ethics.
Put a link.
That's great. Yeah, great idea. Yeah. Okay, so that's all we have for today. But if you like this, then please don't forget to subscribe to our channel, and we will see you next time. See you later. Bye.
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 And in case, if you're in doubt of what is quantum or not, you may also ask us.
Yes, and you can invest in our channel.